We are going to use this video to do some examples of the formulas that we just talked about in the last video. So our formulas in the last video, if you remember, were circumference, which was 2 pi r, area of a circle, pi r squared, arc length, which was arc measure over 360 degrees times 2 pi r, area of a sector, arc measure over 360 times pi r squared, and area of a segment, which equals the sector area minus the triangle area, and the triangle area we usually do by base times height divided by 2 until we get to a future lesson where there's one new formula for area of an equilateral triangle. Alright, let's do some examples. I think I have about 10 examples here, so copy the picture down, pause the video if you need to, because I'm just going to show you the picture. I'm going to get started pretty quick on each of them. So I would recommend trying to do some of it on your own. All right, sometimes they're a little bit more difficult. It might just be better to do them together with me, and then make sure you can do them on your own as needed. All right, so our first circle, we have 14 inches, and I'm asking you to find the circumference. That's what C stands for. All right, so our formula, circumference equals 2 pi r. So this is going to be a pretty easy one. So 2 pi 14. 2 times 14 is 28. Pi inches, done. All right, that's it. Very, very simple. Next one's a little harder. This time I told you the circumference, and I'm asking you to find the radius. Okay, but we're still going to use our formula. Circumference equals 2 pi r. The circumference is 45 pi, so I'm going to put that where the C is, equals 2 pi, and our radius is x. Our goal is to get x by itself, so this turns into an algebra problem. So we need to get x by itself. That means we need to divide. Now pi, remember, is just a number. It's 3.14 and a bunch of other decimals, so we treat it like a number, which means I can add, I can subtract, divide, multiply, whatever. So I'm going to divide by 2 pi. The 2's cancel, the pi's cancel. I'm going to divide over here by 2 pi. Pi cancels. X equals 45 over 2, and we can leave it like that. Now this one I didn't actually give you a label on, so we'll just label it with units. Okay, well, that could be feet or centimeters or whatever. All right, and you don't need to go to decimals on something like that. You can just leave it as a fraction. All right, next one. The length of arc ABC. Make sure you realize we're talking about this length, okay? So we're not talking about the minor arc, we're talking about the major arc. All right, formula was arc length equals arc measure over 360 degrees times 2 pi r. So our arc measure is not 140. Make sure you understand that. So we're dealing with the major arc. This is 140. So the two arcs together equal 360. 360 minus 140 is 220 degrees over 360 degrees times 2 pi 6, which is over 1. Remember, the degrees cancel off. The zeros we can reduce, that's dividing by 10. We can do a little more reducing. These are both divisible by 2, so 11 and 18. And now I can do more reducing this way if you understand it. If not, just multiply straight across and reduce at the end. 11 times 2 is 22. 22 times 6 is 132. Don't forget pi. 18 times 1 is 18. We need to reduce here. They are both divisible by 2. That would give me 66 pi over 9. Those are both divisible by 3, so that's going to give me 22 pi over 3. I can't reduce any farther. My label, it's a length. So I'm going to use my M, that's for meters, and there's our answer, 22 pi over 3 meters. Okay, look at the next one. This one's a little harder again. The length I told you is 15, and you have to solve for x. So our formula said arc length equals arc measure over 360 times 2 pi r. So let's start filling in the stuff we know. We know the arc length is 15. We know the arc measure is 120 over 360 times 2 pi, and the radius, if you look back at the picture, was x. We don't know what it is. I'm going to put that over 1. I'm also going to put this over 1. All right, now I'm going to do some reducing if I can. Cross off the zeros, which is the same as dividing by 10. 12 and 36 can become 1 and 3. Let's multiply straight across. Now you can't multiply here. You don't do 15 times 1 times 2 because there's an equal sign. So just 1 times 2 times pi times x is 2 pi x over 3 times 1 is 3. And then this 15 and the 1 and the equal sign. Now, the reason I put the 15 over 1 is because now we have fraction equals a fraction. So what do? We cross multiply, right? So 15 times 3 is 45 equals 2 pi x. Okay, so 45 right here. 2 pi x times 1 is just 2 pi x. Got to get x by itself. We did something like this earlier where we divide by 2 pi. Pi and 2 cancels. We divide over here by 2 pi. I cannot reduce this. Pi is in the denominator. Leave it there. It's just like a number. You can't just magically move that number up to the top. But I'm going to get some of you who want to do that. You're going to want to put 45 pi over 2 or something like that. It's 45 over 2 pi. Now, this is a little bit weird. I'm going to show you something on the calculator with this one. Now for right now I'm just going to leave it like that. Label, it's a radius, so that's just a length. My label they told me right here was centimeters, so this is centimeters. Now if I asked you to find this one as a decimal, okay, let's take a look at what that would look like. So 45 divided by 2 pi. A lot of you are going to want to do 45 divided by 2 pi. This is going to give you a wrong answer of 70. Now think about that. Is there any way that this radius would be 70 and just have this distance be 15? This distance, if you actually follow that distance, is actually longer than this. So 70 doesn't make any sense at all. So what in the world's going on here? Well, what happens is your calculator follows order of operations. So it takes 45 divided by 2 and gets 22.5 and then takes 22.5 times pi because that's exactly what you told your calculator to do. So, but that's not what this right here means. This means I need to multiply 2 and pi first and then take 45 divided by whatever that number is, 6 point something. Okay, so how are we going to do that? We're going to use parentheses. 45 divided by parentheses 2 pi. Now I'm telling my calculator to do inside the parentheses first. Then do the division. Much different answer. 7.16. Okay, so make sure if you do have pi in your denominator that you use parentheses correctly if I ask you to go to a decimal. And if not, just leave it in the denominator and that's fine. Okay? All right, let's do this one. I'm going to have you solve for the angle this time. So we kind of got 3 problems going on here, all with arc length. Okay, I give you the radius and the angle, you find the arc length. In this case, we had to find the bigger angle though, the bigger arc measure. Okay, on this one, the radius was missing. But I told you the other 2 things. I told you this length, and I told you this angle. Now, I'm going to tell you the length and the radius, but not the angle. Okay, so any of those 3 things can be missing. Okay, so let's start with our formula again. Arc length equals arc measure over 360. I'm not going to put degrees because we know they cancel off. Okay, times 2 pi r. All right, arc length. I told you the arc length was 8 equals, I'm going to put that over 1. I'm going to move my equal sign down a little bit. Arc measure, I don't know it, so x over 360, but it's x degrees over 360 degrees, so the degree symbols cancel, times 2 pi, and the radius is 5, which is over 1. 8 over 1 equals x times 2 times pi times 5. Well, I can multiply the 2 and the 5 together and get 10. And then I still have my pi and I still have my x over 360. Now we can do a little reducing here if we want to, or we can cross multiply right away and reduce at the end. I'll show you that method. So we're going to cross multiply. 10 times pi times x times 1. Well, that's just 10 pi x. And 8 times 360 is 2,880. So now we got to get x by itself. So in this case, we're going to divide by 10 pi. Pi cancels, 10 cancels. Come over here, divide by 10 pi. We can reduce by 0 here. Cross off a 0, or reduce by 10, which is the same as crossing off a 0. All right, so I get 288. Don't write 288 pi, make sure you put 288 over pi. Now that was an angle, all right? Now it already had the degree symbol here, so I don't need to put it here. If you do, it's okay, but you don't need to. Now once again, if you made a mistake and you put this, x equals 288 pi, you forgot that pi is in the denominator, it needs to stay in the denominator, and you did it like this, check your answer. 288 pi. You're telling me that this angle is 904 degrees. Well, that doesn't make any sense at all. Now, what if I did 288 divided by pi? 91.67 degrees. Look back. Does 91.67 degrees make more sense? Yeah, it makes a lot more sense. So that's why we gotta make sure we keep pi in our denominator here. Okay? All right, let's move to area of a circle. Area equals pi r squared. Remember, anytime, pause the video, copy the picture down real quick and try it on your own. All right, and sometimes when they get a little harder, you may not want to. You can just kind of follow along. This one up here was harder. One you might not want to try on your own, but if you feel like you understand this stuff, go ahead and do it. Okay, so area equals pi 8 squared, not 16 squared. 16 is the whole diameter. All right, you can't just stick 16 in here and say it's pi 16, because 8 squared, remember, is not 16, it's 64. We usually put pi seconds. Usually put number, pi, label. What kind of label do I use for area? I use centimeters squared. So number first, pi second, label last. Okay, that was a pretty easy one. Okay, let's look at a little bit harder. We're going to move straight to sector area. Okay, there's not a whole lot of examples to do a circle area. Now, I could give you the area of the circle and have you solve for the radius. Okay, it's not too difficult. You just pi r squared equals whatever, divide by the pi, and then you have to take a square root. Okay, all right, so find the shaded area. So what was our formula? Our formula was area of a sector equals arc measure over 360 times pi r squared. Okay, so shaded area. All right, so see if you can get that whole thing there in the frame. All right, here we go. I don't know this is what I'm trying to find. So it equals arc measure, which is 150 over 360, remember the degree symbols are going to cancel, times pi 9 squared, which I'm going to put over 1. Zeros, dividing by 10, a little more reducing, divide by 3, I can do 5 and 12. You cannot reduce 12 and 9 and say, hey, they're both divisible by 3 because the 9 is being squared. Okay, so let's just leave that. Now we might square it right now and do 81. Then you could reduce, but you don't have to. 5 times 81 is 405, don't forget pi, over 12 times 1 is 12. Now we can reduce at the end, they're both divisible by 3. Gives me 135 pi over 4. Label for area is something squared. Let's look back here, it said feet, so I'm going to put feet squared. Okay, next one. Shaded area is 36 pi. Okay, so this one's a little bit different. We're going to have to solve in this case for x. Gave you an angle. All right, remember though, the area is over here, so it's a little bit different. All right, here we go. Area of a sector equals arc measure, and it doesn't say angle. That's why we don't always use the angle. We have to actually use the arc measure, times pi r squared. All right, do some math. The area of the sector I told you is 36 pi. I'm going to put that over 1 equals, all right, hold on, my kids are getting a little loud. Let me tell them to be quiet for just a second. All right, sorry about that. Here we go. 36 pi over 1 equals arc measure, not 165. 165 is this arc. How do I find this arc? I do 360 minus 165, that gives me 195 over 360 times pi x squared, which is over 1. You cannot reduce here and here. Okay, you cannot reduce across an equal sign. Right? Let's do a little reducing here though. Okay, they're both divisible by 5. No zeros on this one to cancel off, but I can divide by 5. Gives me 39. This gives me 72. I could divide by 3 now. 13 and 24. Okay, looks like that's about as far as I can go. Let's multiply. So I get 36 pi over 1 equals 13 pi x squared over 24. Let's cross multiply. 24 times 36, so use your calculator as necessary on something like that. That's 864, don't forget pi, equals 13 pi x squared. We multiply by 1, it doesn't really change anything. Okay, now I'm going to divide by 13 pi. Pi's cancel, 13's cancel, divide by 13 pi, pi's cancel. Let's try 864 divided by 13. It's a decimal, we don't want that, okay? Now, I have 864 over 13 equals x squared. Can I reduce that? 13 is only divisible by 13 and 1, and we already checked on our calculator, 864 divided by 13 didn't work, so we're going to take a square root. Now, how do we take the square root of a fraction? I'm going to move up here and do this. So the square root of a fraction, so x equals the square root of 864 over 13. You can take the square root of the top and the bottom separately. 864, let's break that down a little bit. 8 times 108, 2 times 4, 2 times 2, 9 times 12, 3 times 3, 4 times 3, 2 times 2, and sometimes you'll notice pairs faster along the way, but I have a 2 and a 2 and a 2. That's that one, that one, that one. And I got this one and this one. And I got a 3 and a 3 and a 3. And I think that's everything. Okay, so I got a pair of 2's, another pair of 2's, pair of 3's. Pairs go outside. 2 times 2 is 4. 4 times 3 is 12. 2 times 3 back inside is 6. Okay? Over root 13. Remember our rule from earlier in the year? We don't like roots in the denominator, so we multiply top and bottom by root 13. I multiply this by the thing that's also under the root. So 12 root 78 over 13 times root 13 times root 13 is just 13. I look for reducing. There is nothing I can do there. Root 78. Well, maybe I can simplify that. Let's check real quick. Well, I already know it's 13 and 6. 2 and 3. No pairs. Okay, can't do that. Here's my answer, and that was a radius distance. Okay, so remember we're trying to find the radius. The label is inches squared for area, but this is just inches. So I left some room here to put inches in. That's a pretty tough one. Okay, honor students, you definitely need to be able to do something like that. CP, I probably wouldn't give you something quite that hard on a quiz or a test. All right, but maybe one in your homework, something like that. I don't know. All right, 2 left. Find the shaded area. Okay, this remember is called a segment. Our formula for a segment was sector area minus triangle area. Okay, so sector area, arc measure 90 over 360 times pi r, which is 18 squared over 1, minus my triangle base, 18 times height, also 18. Remember, radius never changes. So 18 times 18 over 2. All right, little reducing. 90 and 360 goes all the way down to 1/4. 18 squared is 324. So 324 pi over 4. 18 times 18 is 324 over 2. This reduces to 81 pi minus 162. Remember, we put this in parentheses. We put our label outside our label, and our radius was millimeters. That's what mm stands for, is millimeters. So we're going to put millimeters squared for the area. All right, last one. Honor students, you got to be able to do this one. CP, you don't have to. You can actually shut this down with just a little bit of a couple minutes left. Honor students, you definitely need to be able to do this one. This one's a little harder because of the triangle area. Now, I will say that CP students, if you think you want to go into honors next year, you should pay attention because these are the types of questions that are going to get harder as you go. All right, here we go. Starts off the same way, sector area minus triangle area. All right, sector area. The sector area is pretty easy. It's still arc measure 120 over 360. I didn't put degrees, I know they're going to cancel off, times pi, 20 squared, which is over 1, minus. Now the triangle area is a tough one here. Base times height divided by 2 doesn't work because the 20 and the 20 aren't meeting at a right angle. So what I'm going to do is I'm going to flip this whole shape this direction. And I'm going to think about this as my base and this as my height. So I'm going to draw that out off to the side, and we're going to work on this for a little while. So I've got a 120 degree angle up top. I've got a 20 for each radius, so they're the same. And I'm going to draw a dotted line here and put a right angle. We know that this angle up here is 120, but in an isosceles triangle, when we draw the altitude, that splits it evenly into 60 degrees on each side. And hopefully you're starting to think already about a 30, 60, 90 triangle. Well, what do we know about 30, 60, 90 triangles? All right, I'm going to call this H. I'm going to call this X. It's not quite my base because it's only half of my base. All right, 30, 60, 90, 1, root 3, 2. Okay, let's solve for H. That's pretty easy. H over 1 equals 20 over 2. It's already over 1, so H equals 10. Okay, let's go solve for X. X over root 3 equals 20 over 2. We'll cross multiplying. 2x equals 20 root 3. X equals 10 root 3. Excuse me. All right, now x though only goes from here to here, so the whole base is actually double that, which actually takes us right back to this, 20 root 3. Okay, so my base is 20 root 3, my height is 10. So let's come back up here and let's do that for our triangle. Base 20 root 3 times height 10, don't forget over 2. Base times height divided by 2. All right, now we can do some math. A little reducing here and here, 1/3. 20 squared is 400. 1 times 400 is 400, don't forget pi. 3 times 1 is 3. 20 times 10 is 200. Root 3 over 2. Reduce. 400 over 3 does not reduce, so we're going to leave that alone. 200 over 2 does reduce to 100. Root 3. Parentheses. Label is going to be something squared. They told me it was inches, so inches squared. Now we can actually type this into our calculator if you really want to. You just gotta be careful typing it in. So let me show you what that would look like if we wanted to type it in and come up with some kind of approximation, some kind of decimal answer. So I'm gonna take 400 pi over 3 times 100 root 3. So 400 pi, oh, and I hit E, wrong one, pi, divided by 3. You can put parentheses around the 400 pi, but you don't really have to because your calculator will do the multiplying in order from left to right. So it'll multiply and then divide, so that's fine. Minus 100 root 3. Enter. 245.67 square inches. Right? That's it. That's examples for this lesson. So make sure you know your formulas, make sure you know how to use them, make sure you know how to cross multiply and solve for x when necessary. And we'll do some more examples for chapter 11 in a little while.